Now we will discuss about ideal gas equation. See, ideal gas equation means it's an equation used for an ideal gas. Okay. So what exactly is ideal gas? See, ideal gas means an gas in which uh, you are neglecting the forces between these two molecules. Okay, you are neglecting the forces between these two molecules, and also the volume of these molecules itself is neglected. Those gases are known as the ideal gases. See, the volume of the gases are discussed, and also the forces acting, intermolecular forces are also neglected, that are very low, right? So ideal gases are usually um, so almost all gas behave as ideal gas when it is at low pressure and high temperature. Low pressure and high temperature. See, that means these molecules are far apart, so there are no considerable intermolecular forces between them. So this is called an ideal gas, and ideal gas obeys equation that is called ideal gas equation. So this equation can be used only for an ideal gas, only when you assume the gas to be an ideal gas. And this equation, you can see that the terms are pressure, volume, mass, uh, gas constant, characteristic gas constant, and T, temperature. Out of this, you have already an idea about pressure, volume, mass, temperature, etc. But let us see what is R. See, this is another way of writing ideal gas equation. That is P is equal to m by V into RT. Okay. See, this m by V, you know that mass by volume is density. Okay, it is P is equal to rho RT. This is the rho is the density. Pressure P is equal to rho RT, and this R is the characteristic gas constant, and PV is equal to, see, this is another way of writing ideal gas equation. Note that this PV is equal to N R bar T. Here N is the number of moles. Here it was mass, here it is number of moles. R bar is the universal gas constant. Okay, here it was called characteristic gas constant. Then you have the temperature. So this is the universal gas constant. We will see the relationship between these two. N is the number of moles, M by M. This is the number of moles. See, number of moles is related to mass by this formula. This is number of moles can be calculated by mass of the gas by molecular weight of the gas. For example, you have nitrogen, you have 28 uh, gram. Okay, so its molecular weight is 28. So you have number of moles is equal to 1 mole. Number of moles will become 1. This is the difference. So m is the molecular weight of the gas. So PV is equal to m by m r bar t. Okay, m by m r bar t. See, if you substitute this n, this here. Okay, so it is m by m r bar t. So it will become m into r bar by m into t. See, this r bar by m is called characteristic gas constant. This is how these two are related to each other. Okay, if you divide by mass, molecular weight of the gas, then you will get characteristic gas constant. For example, this characteristic universal gas constant is equal to 8.314 kilojoule per kilogram mole Kelvin. This is the unit of R bar. This we should know this value to solve almost all problems. For air, mass is approximately equal to 29 molecular because uh, The main component here is nitrogen, that is 79% is nitrogen. So nitrogen molecular weight is 28, and then you have oxygen. So altogether it comes around 29. So you will get R as 287, um, 0.287 kilojoule per kilomole. Kilogram Kelvin. Okay, note the unit. Here it is kilojoule per kilomole. Here it is kilojoule per kilogram. Okay, and you have here it is 0.27. It is kilojoule, not joule. Usually in problems we use only joule. So R is equal to R bar by M. Okay, this is all about ideal gas equation. So we will use both these forms of energy throughout. So you should know what is number of moles and characteristic gas constant and universal gas constant, etc.